Good day, I am Valentin G. Gonzalez from BSCS 3B, and today we are going to discuss about load balancing and how to achieve load balancing in cloud computing. So let's start. So first, what is load balancing and how does it work? Load balancing is a process by which network or application traffic is distributed across multiple servers in a server farm or a server pool. The fundamental idea behind load balancer is to avoid overloading compute nodes by routing clients' requests or traffic to other potential idle nodes. Network devices or software called load balancer are placed between client devices and backend servers. These are responsible for receiving and routing incoming traffic to servers which can fulfill requests. So here we can see in this diagram that there is the two clients that will be request any information down to the router and switch it to the load balancer and then to our servers. So how does it affect the business? Load balancing has become an effective way for business to keep up with rising demand and ensure that their applications are up and running for users. Today's business receive hundreds and thousands of client requests per minute to their websites and applications. During peak season or hours, this traffic can spike up and even more. Servers are under pressure to keep up and respond with high-quality media including photos, videos, and other application data. Any interruption or downtime in these applications can result in below par experiences and turn away users, resulting in loss of profits. At the end of the day, load balancing is about helping businesses effectively manage network traffic and application load in order to give end users a reliable, consistent experience. So, what is load balancer? A load balancer is a device or process in a network that analyzes incoming requests and diverts them into relevant servers. Load balancer can be physical devices in a network, virtualized instances running on a specialized hardware or virtual load balancer, or even software process. It could also be incorporated into application delivery controls or ADC network devices designed to improve the performance and security of application in general. So in the first figure, we will see an diagram or a example of a software load balancer, while in the second figure, we will see the hardware load balancer. So layer 4 or L4 load balancer. This load balancer make the decisions on how to route traffic packets based on the TCP or UDP ports that they are used and the IP addresses to their source and destination. L4 or load balancer do not inspect the actual contents of the packets but map the IP address to the right servers in a process called network address translation. So what are the differences about these two, TCP and the UDP? So TCP, Transmission Control Protocol, when the web server sends an HTML file to the client, it makes use the HTTP protocol. The HTTP program layer then requests the TCP layer to the set of connection and then send the file. TCP stack then divides the file in the form of packets. Number of them finally forwards them to the Internet Protocol layer to deliver. So while the UDP user datagram protocol is a faster but less reliable than TCP, another common transport protocol. In a TCP communication, the two computers begin to establish a connection via automated process called handshake. Only once this handshake has been completed while one computing actually transferred the data packets to the other. So this is the diagram or the figure. In this figure, we will see the proper process of how layer 4 occurs. So this is the client requests the information and this is the load balancer and goes to the proper servers and then reply to the client. So layer 7 or L7 load balancer. Load balancer L7 load balancer act the application layer and are capable of inspecting HTTP headers or SSL rather, session IDs and other data to deceive which servers to route the incoming request to and how. Since they required additional context in understanding and process client requests to servers, L7 load balancer are computationally more CPU intensive than L7 loader balancer but more efficient as a result. So how does load balancing work? Load balancing or the load balancer could take the form of hardware devices in the network, or they could be purely software-defined processes. No matter which forms they came in, they all work reversing network traffic to different web servers based on the various conditions to prevent overloading any one server. So this is the example of the load balancing. So the visitor, or we can call this as a client, and goes to the request of the load balancer. So maybe we can pulse into the server 1, maybe pulse into server 2. So the key point here is, think of a load balancer like traffic cops, redirecting heavy traffic to the less crowded lanes to avoid congestions. Load balancer effectively manage the seamless flow of information between application servers and endpoint device like a PC, laptop, or tablet. The servers in question could be on-premise, in a data center, or in the cloud. Without a load balancer, individual servers can get overwhelmed and application can become unresponsive, leading to delays in response, poor user experiences, and loss of revenues. Just like in the scenario of in the road that there is the cups, which we can be compared as the load balancer, and the commuters who can be compared as the clients. So which the load balancer or the cops or the traffic enforcers who are handled to the traffic will give the way or the best route for them to choose whether for a good flow of the traffic to avoid heavy traffic and delays on their destinations. How does software load balancing work? Software-based load balancer on the other hand, can deliver the same benefits as hardware load balancer. While replacing the expensive hardware, they can run on the standard device and thereby save space and hardware costs. Software load balancer offer more flexibility to adjust and changing requirements and can help you to scale capacity by adding more software instances. They can also easily be used for load balancing on the cloud in the management, off-site solution, or a hybrid model with in-house hosting as well. DNS load balancing is a software-defined approach to a load balancer. Here, clients' requests to a domain within the domain name system or DNS are distributed across various servers. Every time the DNS system is responds to a new client request, it sends a different version of the list of IP addresses. So, what are the benefits of load balancing? So, first is scalability to meet traffic spikes. Load balancing helps businesses stay up to the traffic fluctuation of spikes and increase or decrease servers to meet the changing needs. This helps businesses capitalize on sudden increases in customers' demands to increase revenue. For example, a commerce website can expect a spike in network traffic during holiday season and during promotion. Second is redundancy to minimize downtime. It is not uncommon for website servers to fail in times of unprecedented traffic spike. But if you can maintain the website on more than one server, you can limit the damage that downtime on any single server can cause. So flexibility to perform maintenance. The ability to divert traffic to a passive server temporarily also allows developers the flexibility to perform maintenance work on faulty servers. You can point all traffic to one server and set the loader balancer in unstable mode. Proactive failure detection. Load balancing helps business detect servers outage and bypass them to distributing resources to unaffected servers. This allows you to manage servers efficiently, especially if they are distributed across multiple data centers and cloud providers. So I hope that you understand about all about load balancing, and that's all. Thank you.